I wanted to make an automatic whiteboard eraser for my math teacher, Mr. Perna. To keep it on the whiteboard, I used a magnet I had lying around. I went through several iterations of the 3D printed frame, which housed the magnet and battery with screw holes for the other electronics. Testing it for the first time, there wasn't enough grip on the front wheels, so I glued some magnets I found to the front axle. This still wasn't enough, so I used these neodymium magnets and it worked well. For the computer vision algorithm to detect whiteboard markings, I originally opted to detect whiteboard edges and find the car's absolute position. But when I realized that wasn't necessary, I instead went for a method that filters pixels by brightness, then takes the largest white blob as the whiteboard surface and assumes that holes in the white blob are markings, proceeding to pathfind to said markings. Neuroscience labs struggle synchronizing their diverse recording devices. Clocks can drift during experiments, destroying data. I built neurokairos to solve this by connecting to GPS atomic clocks with Raspberry Pi. The challenge was making it work with any equipment without modifications. I disciplined the Pi's clock to GPS satellites, then distributed timing through both network protocols and physical iRig timecodes, voltage pulses that any device can record. I validated the system against 30,000 Hz electrophysiology, finding that Python wasn't precise enough, so I had to rewrite the entire thing in C to achieve an average error of 33 microseconds. I fine-tuned a small LLM using my messages, downloaded from Discord and Instagram, making a Discord bot that impersonates me, hosted on a Raspberry Pi at home. I originally used an 8 billion parameter model, but instead went with a 3B model because the 8B would have taken a month to fine-tune on my machine. I also quantized to Q4 for quicker inference. It liked asking Meta AI to generate images, likely because I do that a lot in chats, and so I decided to also give it image generation, all hosted on a Raspberry Pi CPU. For the 2025 FRC game, I used a vector field pathfinding algorithm for navigation, switching to PID control within 1 meter for precise positioning. The driver presses a button, moving the robot to the nearest branch, and then lifting the elevator and scoring, making scoring easy even during autonomous. One match it tried pathfinding to the enemy reef because it thought it was the opposite alliance, so I made it only work when it's on its own side.